All right, hello 20-1 students. Welcome back. We are on our second lesson of the first chapter. So remember that last time we looked at arithmetic sequences. So we were looking at patterns of numbers that occur when you start with, one given number, which we called T1, and then you add the same number over and over and again to get a sequence of numbers. So remember the number that we add is called the common difference, which is represented with the variable d, and n is talking about how many of those terms you would get. So basically if you keep adding, like if we have the sequence 5, 10, 15, 20, then we started out with T1 being 5. We had a difference of 5 because we went up by 5 every time. And say if the sequence ends at 20, then we would have 5, 10, 15, 20, so we'd have a total of 4 terms. So 20 would be have an n value of 4. Now we're going to introduce something new in this lesson where we're going to be looking at the sum of those numbers that are in an arithmetic sequence. And so when we're looking at adding those numbers together and finding how much do they add to in total, so remember the word sum in math always means the total after addition, that's when we call it an arithmetic series. So it's when we're concerned with adding all the values together, adding all the terms. Okay, so what are some of the key ideas with this? Well, an arithmetic series is a sum of terms that form an arithmetic sequence. So like I just said, so for example, if we have 3 plus 6 plus 9 plus 12, so this is our arithmetic sequence here. It has 1, 2, 3, 4 terms. The common difference is 6 minus 3 is 3, 9 minus 6 is 3, 12 minus 9 is 3. So our common difference is 3, right? Our first term is 3. And when we're thinking about the sum, for something simple like this, we can go in and just add, right? 3 plus 6 is 9, plus 9 is 18, plus 12 is 30. So we would say the sum of these 4 terms is 30. However, when we start looking at much more complex series, or if we have like way more than 4 terms, we don't want to have to go back and try and add everything up. And so we're going to be moving forward, we're going to be using a formula that's going to help us to find these values. Or if we have the sum, for example, can we find out what the first term in that series would be, or can we figure out how many terms there were? And so this formula is going to allow us to work with the numbers that we have to get what we're looking for. So the first formula we're going to look at is this one here, where the sum of any number of terms, so remember n represents our variable number of terms, is going to be equal to half the number of terms. So we take the number of terms and divide it by 2, multiplied by all together whatever this value adds up to, 2 times by the first term, plus the number of terms minus 1 multiplied by the common difference. Okay. And so let's see, we also have a variation on this formula that we can derive, because if you remember last lesson, we had, let's see, a formula for Tn. Tn is equal to T1 plus n minus 1 times by d. And so what you might recognize here is a similarity there, right? T1 plus n minus 1 times by d. The only difference is that we start out with 2 of those t's in this formula. And so essentially within this formula, we have the formula we worked with in our last lesson. And so if we account for that, we know that one of these t1s is equal to Tn, because Tn is equal to T1 plus n minus 1 times by d, right? And we have all of that here, but we just have an additional T1. And so essentially what we can do then is say we still have this n over 2, but we can expand this out so that it's T1 plus n minus 1 times by d, which is that formula that we had. So this whole part is equal to Tn, right? And so then what we can do to make our formula even simpler is to say, okay, the sum of our numbers is equal to n over 2 multiplied by the first term plus this whole component, which is equal to Tn. And so this is going to be handy if we're given Tn, right? We don't have to use this big, huge, long expanded version. We can just plug in the Tn and you can see that the formula looks quite a bit simpler. Of course, both of these formulas are going to be useful to us depending on what information we're given in the question. So this formula is going to be useful if we have the information for Tn. This one is going to be information if we have information about like the number of terms, the difference, T1, or the sum, for example. Okay, I don't think I need to review any of those terms anymore, so let's get right into trying some practice problems. So the first one says, find the sum of the first 60 terms of each series. Okay, so in our first one we have 5 plus 8 plus 11. So what are some of the things we always want to do? If you remember from last time, we want to pull out what are the variables we know. So always starting out with, what do we have here? T1 is that variable, and we call it 5, or it is 5, not we call it. What is another thing we want to know? Well, if we look at, these are going to be our two formulas we're working with today. So we have T1. Do we have n? Well, not really, right? Because we don't know. Oh, actually, yes, we do, because we were told here the first 60 terms. So we're going to be looking for n equals 60. And then what else do we need? So we have T1, n, which is there and there in this formula. And then d, the difference, remember, is always going to be one number minus the previous number. So 8 minus 5 or 11 minus 8. And both of those will give us a difference of 3. Okay. So we can look and see, is it possible to use this simpler formula? Well, we would need to know what the 60th term is, and we only know that there are 60 terms. We don't know what the 60th term is. So it's going to make more sense for us to use this formula in this case. Okay, so knowing that, we can go right ahead and plug it in. So I'm going to not write the whole formula out on its own, but I'm going to write it filled in with our values. So we want to find the sum of the first 60. So we're going to change that n to a 60 because we know which one we're looking for. Then that's going to be equal to n, which we said was 60, divided by 2, multiplied by 2 times by T1, which is 5, plus n minus 1. So n is 60. Now it's up to you guys how you kind of do this. You could, like, personally, if I was working through this, I would do the subtraction right away. So I would say 60 minus 1 is 59. And then I multiply it by d, which is 3. But you'll notice that when I write these out in the filled-in notes, I expand it and I do every single step. But that's mostly just so that you guys can see, like, if you were only reading the notes, you would be able to see what I was doing and kind of connect, like, why is this all of a sudden a 59, right? So I would have written in the 60 minus 1. With these notes, I'll kind of skip ahead, but I'll still be writing out the steps that, you know, you should probably be doing. This would be the minimum number of steps that you should be doing on a test so that I can see your work. Okay. Now we can start just working on simplifying. So I don't need this sheet anymore. I'm going to say we have sum of 60. 60 over 2 is 30. And then bracket 2 times 5 is 10, plus 59 times 3, which is 177. And then simplify again. So now, again, if you wanted, like, I think in the paper I wrote out this expanded, or I like added those together. But if you go 177 plus 10 is 187 times by 30, we can say that the sum of 60 is now going to be 561. Okay, so this is quite a bit shorter than the filled-in copy that's online, but this would be kind of the minimum number of steps that I would expect you to show me on a test so that I could pick up if you made a mistake, like what if you put a 6 in here instead, right? Okay, next one, again, pick out all of your variables. So I'm not going to pull up the formula sheet again because we know we want T1. So T1 is negative 6. Oh, and now here I go, not labeling it. build up here. Okay, so T1 equals 6. Oh, jeez, you guys. It's -6, and that is very important to keep that negative in there. There we go. T1 is 6, -6. And then what about N? We're still looking for the first 60 terms, so that doesn't change. And then the difference, just make sure you're being really careful with this. So what you always want to do is keep the value together with the number, right? So we have -8 here and -6 here. So if we want to find the difference, it's going to have to be -8 is the second term minus the first term minus -6. So remember, -8 minus a negative actually ends up adding it. So we end up with -8 plus 6, which gives us -2. Okay, so now we have all of our variables. Again, we don't have Tn, so we want to stick with this same formula as we did here. So basically, we're going to have Sn equals n over 2. N is 60 over 2. And then multiplied by 2 times by T1, which was -6, plus n minus 1. 60 minus 1, which is 59, times by our difference, which is -2. Now, what you might want to do here, I would recommend going through and doing this math on your own. So pause the video, put this in your calculator or whatever you need to do. If you can do it in your head, that's great. Mostly the reason why I'm asking you to do this is because what a lot of students end up struggling with is order of operations in their calculator. So if you go through and you're not getting the correct order of operations, you'll end up with the wrong answer here. And so the quicker or the earlier on that you can put things into your calculator and make sure you're getting the right answers, the more comfortable you'll get with how your specific calculator works, because not all calculators set up order of operations the same way. For some of them, you really need to like baby step them through and make sure they're doing it right. For other ones, they can kind of figure it out on their own. So I highly recommend that when we go through problems like this on the notes, you enter in these numbers into your calculator to make sure you're getting the right number so that you don't get to a test, do all the right work, and then get the wrong number answer, right? Because you're not doing order of operations, especially because on multiple choice questions, a lot of times there will be answers that account for a calculator that's not doing the correct order of operations. So you want to make sure that you know ahead of time going in how to do that properly. So if you pause the video and you go through, and then you can start it again and make sure you get the same number as me. So essentially all we're going to have is 30 times by 2 times -6 is -12. 59 times -2 is -118. Okay. Oh, I need a double bracket there. And so now -12 plus -118, which is basically minus 118. So it's going to be -130. And 30 times by -130 is -3900. Okay. Oh, I actually... Silly. I was putting in SN the whole way through. It's not going to be like, I wouldn't dock you guys marks on this, but you should try and get used to writing the proper subscript. So S60, because that is what we were looking for. Okay. All right, let's try a different one. Find the sum of the arithmetic series, and this is what we're given. So in this case, we're given the last number, but we don't know the number of terms, right? It doesn't tell us. We just have that ... in there. So let's start picking out variables. We know we have T1, which is 5. We have consecutive terms, so we can solve for the difference. So 9 minus 5 is 4. Or 13 minus 9 is 4, whatever. What else do we have? What is this? Try and think about what variable that is. It's the last term in our series, and so it's going to be Tn because we don't know which number it is, so we're going to call that 201. And that's pretty much everything. So now if we look at our formula sheet, we want to see how is this going to work with? What are we looking for? We're looking for the sum, so we're looking for Sn. And so we know we have to pick one of these two. Don't worry about like these ones down here. You're going to find out about those later. So even though they are also asking for SN, they're going to apply to a different type of sequence and series. So just ignore those for now, okay? So we have to pick out of these two, and we want to look at our variables. We have T1, we have our difference, but we do not have our n value. We do have Tn though. So if we look at our second option here, we have T1n, but we're still missing that n value. So we need to think about how can we figure out what that n value is. So basically, if you know that you're going to need to use one of these formulas to get the value, like in this case we're looking for Sn, so we know we're going to have to use one of these to get that value. However, to use either one of them, we're missing this n value. Where else can we get that? Well, one of the things we can use is the formula that we had for our Tn, because if we think about what values we have, like which variables we have, we know the number for Tn, we know the number for n, sorry, did I just say T1? I don't know. We know the number for Tn, we know the number for T1, and we know the number for D, and so the only variable we're missing is n, right? Whereas with this one, we are missing Sn and n. So just always keep in mind you can never use a formula where you're missing two of the variables. Well, actually later on you might be able to, but for now, like if you have two missing variables, you can't solve for either one, right? Because you don't have enough information. So then you need to look to your other formulas that include the same variables. They could be a different formula, so they're not for what you're looking for in the end, but they still have the same variables and allow you to solve for the one that you're missing, which in this case is n. So we can start out by using this formula that we learned in our last lesson to solve for n, and then once we have n, then we can just plug in this formula. So solving for n, we have Tn equals T1 plus n minus 1 times by d. Now, often the temptation would be to start putting in the numbers right away. However, because we don't have a number value for n, and n is in the brackets together with 1, we can't start plugging numbers in yet. First, we need to isolate n from all the other numbers, including this minus 1. Okay, so we're going to work at rearranging this equation before we start putting in numbers. So if we want to get n on its own, remember that to do algebra, we're always doing BEDMAS in reverse, right? To move things away from a variable. So the first things you want to look at is there any addition or subtraction on the side where the variable that you're looking to isolate is? Keep in mind this doesn't include addition or subtraction. That's within the brackets. Brackets are going to be your last thing that you worry about. So we're not going to worry about the n minus 1. But we do have a T1 being added to this bracketed term. So we can subtract, remember always opposite operation. So T1 is positive, so we want to subtract it. And what we do to one side, we do to the other. So that's going to give us, I'm just going to move this formula sheet out of the way, Tn minus T1, and then T1 minus T1 is 0, so we're left with n minus 1 times by d. Okay, so the next thing to get this n on its own, if we move backwards, is going to be any division or multiplication. So in this case, we have the n in its brackets being multiplied by the variable d. So we want to divide, always opposite operation, to remove, and we want to do that to both sides. So d divided by d is 1. Anything divided by itself is 1, right? So then it doesn't change this at all. So now we have Tn minus T1 over d is equal to n minus 1. And basically, once there's nothing else here, this no longer requires that bracket. So on this side, we have n minus 1. So by dividing the way that d, we also kind of got rid of the brackets. So that means we go back to the start and start again. So now is there any addition or subtraction? Well, there's a 1 being subtracted from the n, so we need to move that to the other side. If it's being subtracted, opposite operation is to add it. Negative 1 plus 1 is 0. So we're left with n. And now, because this one is being subtracted from everything on this side, the brackets actually kind of transfer over there. So we're going to have Tn minus T1 divided by D. And all of that was together before we removed these brackets. So this needs to stay in brackets and have that 1 subtracted off of it. Okay, so now here's our formula to solve for n. So now we can plug in our numbers. So we can say n is equal to Tn, which was the 201, minus T1, which was 5, divided by D, which was 4, and then all of that is going to be minus 1. So 201 minus 5 divided by 4. Let's see, I don't actually have that all. So 201 minus 5 is 196 divided by 4 is 49. And then we subtract off. So this whole thing is 49 minus 1. And so we have n is equal to 48. Okay, now that seems like a lot of work, but we're actually not at the end yet, because remember what we're looking for is Sn. But now that we have n, and we have Tn and T1, we can use our simplest formula to solve. So now we can say Sn is equal to n over 2. So we said n was 48 divided by 2. And then in brackets T1, which was 5, plus Tn, which was 201. So we're going to end up with Sn equals 24 times by 206. And then that is going to be equal to 4,944. And so that is our sum for that series. Okay, that was a long one. Last example of arithmetic series is going to be a word problem. So it says the sum of the first 2 terms of an arithmetic series is 19. So usually what we want to do with a word problem is we want to start basically we want to start kind of going through and seeing how would we translate this into math writing, essentially, right? So if it says the sum of the first 2 terms, we know that we represent that with S2, right? The sum of the first 2 terms. And that is equal to 19. The sum of the first 4 terms, so that's going to be S4, is 50. Okay, and then it's asking you what are the first 6 terms of this series. So we basically want T1 to T6. And then also it's asking us, so that's going to be a question mark, and what is the sum of the first 20 terms? So S20. Those are 2 different questions that we're going to have to answer. So how can we start with solving a problem like this? Because this is quite unlike what we've done up until now. So the first thing that we're going to need, so we have, if we want to solve for the first however many terms, we need to know what T1 is, right? Obviously. And then to get each term after that, what else do we need to know? How do we know what term 2 is if we know what term 1 is? Well, we need to know what the common difference is, right? We need to know how much are we adding to T1 to get T2. Because once we know that, we can solve for an infinite number of terms from there on. So we want to know T1. This first 6 terms is telling us we need T1 and we need the common difference. Okay, so remember that in order to do that, we need to solve for what I mentioned to you earlier was like if you are missing more than one variable, like the number of values for variables in a formula, you won't be able to solve for it. And this is where you're going to learn how to do that. And so basically what you need to do is, if we're given the sum Sn basically of two different terms, we need to figure out, we want T1 and TD, or sorry, T1 and D, and so we know that out of these two sum formulas, we want to use this one because it contains both T1 and D. However, like I said, if you're missing two of them, how do we do that? Well, what we're actually going to do is, because 2T1 is going to be the term for both of them, we're going to set up two different formulas and we're going to use them together to solve for the unknown. So this is kind of like, it might not be super intuitive at first, but this is something that you just need to learn and practice. And then once you understand that this is how you can solve when you have more than one missing variable, it'll become a lot more kind of like second nature and something that you'll go to. So for S2 equals 19, basically what we would do is go and fill in. So S is 19 when n is 2. So n over 2 is going to be 2 over 2. We don't have a value for T1, so it's going to be 2T1 is just going to stay the same, plus n. Oh, right, n is going to be, because we're at S2, so it's going to be 2 minus 1. So we have a number value for inside the brackets. And then we have D is going to be our unknown. Now we do want to simplify this as much as possible. So 2 divided by 2 is just 1, which multiplied by anything doesn't change it. So we can essentially just eliminate that one. So 19 equals 1 times by 2T1 has to stay the same, plus 2 minus 1 is 1 times by D is just D. So we can just say 2T1 plus D. Okay. So that's one of our formulas. And now we also want to do the same thing for S4. Okay, so this is kind of our steps. So we have S2 is what we're dealing with there. And now let's look at doing S4. So S4 is 50. And 50 is equal to n over 2. And n for this one is 4, so 4 over 2, multiplied by 2T1, so we don't have a value for T1, so that stays the same, plus n minus 1, so if you wanted, you could just simplify here. N is going to be, in this case, it's 4, so 4 minus 1 is going to be 3, and then still multiplied by D. Okay, so now the only other thing we need to think about is if we can, like, we want to keep this side as simple as possible. So because right now 4 divided by 2 is actually 2, so we're going to have 50 equals 2 times by 2T1 plus 3D. And what we actually usually want to do here is we want to try and keep these two formulas we're working with as similar as possible. So you might want to try and multiply this through the brackets, but then we're going to have 4T1 here and 2T1 here. So we're going to have differences between these two, and we want to try and keep them as similar as possible. Okay, our D's are going to be different no matter what. We can't really change that, but you just want to minimize the amount of differences. So instead of multiplying this through, we're just going to try and move it to the other side, because the other thing is that these two values are of course going to be different. So let's divide that 2 away from both sides. So 2 cancels out. 50 divided by 2 gives us 25. And 2 over 2 is 1, so that cancels out, and we're left with 2T1 plus 3D. Okay, and now this is where we kind of end up with the magic, where we can solve for some of these unknowns. So what we're going to do is we have these two terms and we want to find the difference between them to basically solve for D. So essentially what we're going to do, so this was our step 1, was to set up these two sums. And again, if you guys go to the filled in notes, I have written out instructions, so you can always go back and double check, you know, kind of the explanation of why we're doing what we're doing. So our second step is to find the difference, okay? So it doesn't actually really matter which one you put first or second, you're going to end up with the same values. So 19, actually, you know what I'll do, because I think I did 19 minus 25 on the filled in one, so I'll do it the other way so you guys can see that it doesn't matter. So let's start with this one. 25 is equal to 2t1 plus 3d. Okay, and we're going to subtract this whole statement here, this formula. I don't actually need these brackets. I might just take those out of the equation because we know that those are together anyways. Okay, so 19 times by 2t1 plus d. Okay, and so this is basically just combining like terms. So these are two just straight up number values. 25 minus 19 gives us 6. Carry down our equal sign. 2t1 minus 2t1. These are the exact same variable, right? 2 times by our first term. And so they cancel out. So then we're just left with what is positive 3 times by d minus positive 1d, right? So always just keep in mind if there's no number out front here, it's technically a 1, and you basically just have to use the numbers to solve. So 3 minus 1 is 2, and then we just keep the variable the same. So now if we want to solve for d, we can divide away the 2 from both sides. And so we're left with 2 divided by 2 is 1. So we have d is equal to 6 divided by 2, which is 3. Okay, and if you look at the filled in notes, you'll find that even if you've reversed these, you'll get the same answer as long as you do your negatives properly. So now we know what our difference is. The other thing we needed to know was T1, and the lovely thing that you can do here is, now that we know what D is, if we look at, you can use either one of these. I personally find it's easier to use the one without anything being multiplied by the D. Now we can solve for T1 because we have our sum, we have our difference, and so we only have one missing variable in our formula. So basically now what I would do is say, okay, well 19 equals 2 times by T1, which I don't know, plus my difference, which I did just calculate as 3. So now if I want to isolate T1, I need to subtract 3 from both sides. 19 minus 3 is 16. And 3 minus 3 is 0, so that's equal to 2T1. And then again, just divide outright, so 2 and 2. So we end up with T1 is equal to 16 divided by 2, which is 8. And now we have our two unknown variables. So it might be hard to remember, what were we trying to do here? The first thing, that's why I sometimes like to write it out here, especially because a lot of times on tests, if you're asked two different things like you are in this one, you want the first 6 terms and the sum, students forget about, one or the other of them. So if you've written out your list of variables and you have your 2 question marks, you'll always remember that you have 2 things to answer here. So T1 to T6 is going to be pretty straightforward. T1 we have is 8. And our difference is 3, so it's going to be T1 is 8, T2 is going to be 8 plus 3, which is 11, T3 is going to be 11 plus 3, which is 14, T4 is going to be 14 plus 3, which is 17, T5 is going to be 17 plus 3, which is 20, and T6 is going to be 20 plus 3, which is 23. So there's our first 6 terms, right? So, of course, if I'm handing in this written answer, I'm going to keep that nice and tidy. And then the last thing I need to answer is S20. So in this case, I want to think about what formula is going to work out best for me. We are not given Tn, so we shouldn't be using this formula. So now that means we're going to use this one because we have n, T1, and d. So we can just plug it in. S20 is going to be equal to, our n value for this one is 20 divided by 2 times by 2 times by T1, which we said was 8. Plus n minus 1, n is 20, minus 1 is 19, times by our difference, which is 3. Okay, So then we're going to have 20 divided by 2 is 10. 16 plus 57 is 19 times 3. And then that's going to give us S20 of 16 plus 57 is 73 times by 10 is 730. Okay, so again, just making sure you do your order of operations. First of all, add these up and then multiply outside the brackets. Okay, so that is everything for arithmetic series. You guys have some practice problems to do here. Make sure you check your solutions in the textbook to ensure that you are getting your answers correct, both because this will help you to eliminate problems with your calculator or problems with your technique of how you're following procedures and things like that. Next time we are going to be looking at lesson 1.3, which will be geometric sequences. So we're moving into a different type of sequence and series. So I will see you then.